the second part of chapter 4. So we skipped 4-5 because it's on imaginary zeros, and so we're on to 4-6. So this is the second part of chapter 4. Again, I split chapter 4 into two parts. So this is on rational functions and power functions and root functions. Rational function, what is a rational function? How to find its domain. Identify the asymptotes and interpret the asymptotes of functions, of rational functions. Graph them. And look at different types of rational equations. Right, a rational function is function when you divide. A rational function is the type of function where you have a polynomial divided by a polynomial. Alright, so again, they have to be polynomials in the numerator and polynomials in the denominator. So p of x would stand for a polynomial, q of x would stand for a polynomial. So r of x is a rational function given those are polynomials, and the q part is not 0, right? So the domain is basically figuring out all of the zeros that are in the denominator and throwing them out. That's how you figure out the domain. So that's the first thing we're going to look at is the domain of rational functions. Rational functions are continuous everywhere except at what values cause us to divide by 0. So the zeros of the denominator polynomial, which we know how to find zeros of polynomials. We did that all of the last section. And a lot of our polynomials are going to be quadratic, so we even did that in chapter 3. All right, so we want to find the domains of the following rational functions. Well, the domain is all reals except when my x squared minus 16 equals 0. Now, there's two ways to solve this. Either you can factor it or use the square root property. It factors into x minus 4, x plus 4. And so we have two zeros, 4 and negative 4. And so those are the two ones that if I plug them in, I'm going to get division by 0. And so the domain, if I'm using set notation, is every x such that x does not equal 4 and negative 4. If I'm using interval notation, it's everything between negative infinity to negative 4, everything between 4 and negative 4, and everything from 4 to infinity. There's the domain of that particular function. All right, second example. Very similar, but I changed one little thing, but that one little thing makes a big difference. Again, it's all reals when, except for those where my x squared plus 16 equals 0. And if I go to try to solve this, I move 16 over to the other side, I get a negative, and so if I tried to take the square root of that, it would give me a non-real number. I want only reals. That's a non-real number. And so what that tells me is there's no real number value that will cause division by 0, and so all real numbers work. And so the answer is all reals are the domain. So everything works from infinity to negative infinity would be my set notation. All right, the next example, same thing. Basically, I don't want that to be 0. So I've got to figure out when it is 0, and so this is a quadratic. There's a bunch of ways, again, we went over a bunch of ways to solve it. You can solve it using the quadratic formula. You can graph it, find its zeros. I'm going to factor, this one factors really nice. The factors of x squared are just x and x. Factors of negative 6 that add up to 1 are going to be 3 and 2, which it's a positive 3 and a negative 2, right? Negative 2 times 3 gives me my negative 6. 3 plus a negative 2 gives me my positive 1, and so my zeros are at 2 and negative 3. And so those are the ones I don't want. So my domain is all reals such that x does not equal negative 3 and 2, or using interval notation, everything from negative infinity to negative 3, everything between negative 3 to 2, and 2 to infinity. There's a break at 2 and there's a break at negative 3. Right, the last example. Again, that can't be 0, which this one's a little easier. X minus 2 equals 0. Well, the only value is 2, so it can't be. So the domain is everything. Every x such that x does not equal 2, or again, interval notation, there's a break at 2. So everything from 2 to infinity works, and everything between negative infinity and 2 works. All right, so there's my domain. So rational functions are just a polynomial divided by another polynomial. Unlike polynomials where the domain is all real numbers, rational functions are domains of everything except where the bottom polynomial, the dividing polynomial, is not 0. So I have to find the zeros of the divisor and throw those out. Those are the ones that we don't want in a domain. I have breaks in my functions. Everywhere else is fine. The only place where I have breaks are where my function does not exist, and they do not exist when I get division by 0. Alright, so introducing rational functions, and then we'll get into the behavior of them and asymptotes in the next set of videos.